In this video, I am going to solve this differential equation. This looks like an exact differential equation which has a format of p of x comma y dx plus q of x comma y dy is equal to 0. If we make that assumption, so it's going to be this p of x comma y, and this is going to be your q of x comma y. All right. First, we need to show that partial derivative of p with respect to y is equal to partial derivative of q with respect to x. These two are equal in order to ensure that this is, in essence, an exact differential equation. If it is an exact differential equation, we can go ahead and find the solution. So we need to show the following: del p over del y is equal to del q over del x. So that's the question mark. Is that equal? So let's find del p over del y is equal to del over del y of 4x plus y e to the power x. So that's this one. Now that is pretty easy, right? Derivative of 4x with respect to y is 0. Derivative of y e to the power x with respect to y is just e to the power x. Now let's find del q over del x. So that is going to be del over del x e to the power x, because del q of xy is e to the power x, which is nothing but e to the power x. So this and this are equal. So in essence, del p over del y is equal to del q over del x. Now we are going to go ahead, and now that we have shown that it is an exact differential equation, we are going to go ahead and find the solution, find that potential function that is going to be the solution to this exact differential equation. And we know from our prior knowledge of the theory of exact differential equation is that that function is going to be of the format f of x comma y is equal to some arbitrary constant c. Now our objective is to find this function. Can we do so? The answer is yes. Remember, our p of x comma y is nothing but del of f, okay, over del x. Now what we can do is integrate p of x comma y with respect to x, and then integrate del f over del x with respect to x, and that is going to actually give me f of x comma y. However, we have the p of xy, which is nothing but this 4x plus y e to the power x. Okay, that is dx. That must be equal to your f of x comma y. Now if I rewrite this, I would have f of x comma y is equal to integral 4x dx, right, plus integral y e to the power x dx, or f of x comma y is going to be integral 4x dx is going to be 4 times x squared over 2 plus y is a constant when we are taking integral with respect to x, is going to be y times integral e to the power x dx is nothing but e to the power x. Here we are going to have to add an arbitrary function. Let's call it g of y. Why are we adding this arbitrary function of y? Because of integral that we are taking with respect to x. So this kind of serves as a sort of like a constant. Okay. Now if I simplify it further, I'm gonna get f of x comma y is equal to 2x squared plus y times e to the power x plus the function of y, g of y. So in theory, we kind of have a function f of xy, which is going to be a solution to this function. However, we still do not know what is g of y. Can we find g of y? The answer is yes, we can find g of y. How do I go about finding that? we know that q of xy, which is just e to the power x in this particular case, is nothing but the partial derivative of this function with respect to y. So del f over del y is gonna be equal to q of x comma y. Now if I take the derivative of this with respect to y, I get 0 for the first term, and for the second term I get e to the power x, because derivative of y is 1 and e to the power x is a constant when we are taking derivative with respect to y, and the derivative of g of y is gonna be just g prime of y, as we do not have an explicit format of function for g of y. That must be equal to e to the power x. Now you have e to the power x on the left, you have e to the power x on the right. So if you subtract it, that gives you g prime of y is equal to 0. If g prime of y is equal to 0 and you take the integral of it with respect to y, that should be a constant, right? Prime of y dy, there is nothing but g of y, right? Integral of this, which must have to be a constant, because the derivative of a constant function is gonna be 0. Now if I take this c and plug it into here, there's gonna be f of x comma y is equal to 2x square plus y e to the power x plus some constant. Now we can rewrite this equation in this format. So let's call it f of x comma y is equal to 2x square plus y e to the power x. Now this constant, I'm just gonna ignore it and put a bigger constant, let's say uppercase C, okay? Because if I move it to the right, it's gonna be subtracted from the other constant this function is supposed to be. So we can just combine it and come up with a constant C. So in essence, this is the solution to this differential equation, or to be precise, exact differential equation. I hope that this discussion was helpful. Thank you so very much.